let's get started talking just a little bit about magnetism. First of all, we want to look at what a magnet even is. All magnets are made up of a mineral called magnetite. There's a picture of what magnetite looks like. It's a naturally occurring mineral that's found on Earth. Magnets attract objects that contain iron. Okay, iron is just a type of metal. A lot of different metals contain iron, so magnets stick to most anything that's considered metal. All magnets have one end that's known as the North Pole and the other end that's known as the South Pole. Most of you guys are probably familiar with this, as most of you have probably kind of played with magnets before. A lot of you probably know that the opposite poles are going to attract each other, while the same poles are going to repel each other. Repel means to push away. Okay, and you can see that here. You can see both of these North Pole ends, when they're pushed together, those magnets are actually going to try to push each other away. They're not going to want to stick together. Okay, but the unlike poles, if you put a North and a South Pole together, they're actually going to pull each other together, and that's what's going to cause those magnets to stick together, those unlike poles. So just like gravitational forces and electric forces, a magnetic force can also be exerted when objects are not even touching each other. This force is exerted in the area surrounding the magnet, and it's called the magnetic field. Depending on how strong the magnet is, then that's how big the magnetic field is going to be. The stronger the magnet, the bigger the magnetic field is going to be. You can actually see a magnetic field using something called iron filings. These are just like little iron shavings. This is a picture that shows a magnetic field. This is an image of iron filings with a magnet underneath that's showing that magnetic field, and you can see that they're very similar images. And here's one with a magnet on top. Now, you can't just put a magnet on top of the iron filings. There has to be a plastic, some kind of covering in between there, or all the iron filings are just going to jump onto the magnet and stick. Okay, so materials such as iron can actually be made into magnets. We said that all magnets are made up of magnetite, which is a naturally occurring mineral, but you can also make magnets out of iron. Okay, a moving electric charge, such as moving electrons, which is what we looked at with like electric current, it creates a magnetic field. Okay, so anytime you have an electric current moving through a wire, it actually produces a magnetic field along with that electric current. Okay, since the electrons in each individual atom of a material are constantly moving, you guys should have learned about that last year, how all atoms are constantly moving. If you're looking at a solid, they're just vibrating, they're not moving a lot, they're packed in really tight. If you're looking at a liquid, they have a little bit more freedom to move, and if you're looking at a gas, of course, they can move pretty freely. Okay, so since the electrons in each atom of a material are constantly moving, each atom forms its own little magnet with its own little magnetic field. Okay, when a group of atoms have their magnetic fields pointing in the same direction, it's called a magnetic domain. Different materials, again, such as iron, they have a lot of different magnetic domains. If the material, such as iron, is not magnetized, that means it's not a magnet, then those domains are oriented, or they're facing in different directions. As shown in this illustration, these arrows are representing each magnetic domain within that piece of iron. And you can see those arrows are pointing in all different directions, so it's not magnetized. If a material is magnetized, which means that it's going to be a magnet, then all of the domains are going to be oriented or pointed in the same direction. Now, you can actually create a magnet by rubbing a strong magnet on a piece of iron, such as a nail or even a paper clip, in one direction several times. And it causes, as seen in this illustration, it causes those magnetic domains to all point the same way. And that gives it a north pole and a south pole. Now, Earth has a magnetic field that surrounds it. Earth has its very own magnetic field. This is what allows a compass to work. Okay, Earth's magnetic north and magnetic south poles are not located in the same place as the geographic north and south poles. Okay, so we have what we consider, the North Pole. We say, oh, Santa Claus has his workshop, at the North Pole. That's the geographic North Pole. And that's seen here. The magnetic North Pole is actually not in the same place. When you use a compass, it points to that magnetic North Pole, not the geographic North Pole. And the same thing for the South Poles. The geographic South Pole is over here, while the magnetic South Pole is over here. Earth's magnetic field, it does not stay in one place. It actually moves. The North Magnetic Pole is heading from Canada over towards Siberia. It's actually across the international date line. And so it's moving quite rapidly. And you can see in this illustration in 1900 where it was located and how it slowly moved over during the years.